Hi, this is Martin from MV Drive Services. Welcome to our channel. In this video I would like to talk about availability in drive systems. I know it's an important topic, it has always been important, but my feeling and experience is that the importance is even growing. So, starting, I would like to explain some definitions. Availability, I will denote this as A, can be expressed as the ratio between uptime and the sum of uptime and downtime. So uptime is when the equipment is functional, so it can provide the function. It can be operational or it can be in standby, but it's functional. And downtime, obviously, when it's not functioning. We can classify the downtime into two categories. One is the planned downtime, so this is something that we are planning, that we are expecting. This is normally the service and maintenance work. So if you buy certain equipment, typically in the user manual or service manual, you will find the maintenance schedule that tells you in which intervals what are the tasks that you have to do some inspections, maybe replace some components of the bigger system, and so on. Unplanned downtime is the one that we want to minimize or eliminate if possible. So this is something that comes unexpected. Now when we come to the statistical language, the availability A can be also expressed as a ratio between the MTTF, mean time to failure, divided by the sum of the MTTF and MTTR, mean time to failure plus mean time to repair. This can be simplified. It can be, so availability is the ratio between the mean time to failure and mean time between failure. Be careful not to mix those. They sound similar, but one is the mean time to failure, the other one is mean time between failure. We will work with this expression, so keep it in mind. I will now explain the difference between the two. So what is the difference between MTTF and MTBF? MTTF, mean time to failure, MTBF, mean time between failures. I have here a time axis. F1 is the time instant where the failure 1 occurs. Then it takes some time to repair it. And then the equipment is again functional. And then at some other point of time, F2, the next failure happens. So MTTR, mean time to repair, this is the time required to repair the equipment. And then we have the period when the equipment operates without any failure. And so this is the mean time to failure. And the MTBF is the sum of the two. This is really mean time between failures. So this is the time when failure 1 occurs until the time when failure 2 occurs. So MTBF is always higher than the MTTF because it's the sum. This is quite important because a lot of people just focus on the MTBF, but I would like to put it in a little bit different perspective. Another point I would like to mention is that there are two ways how to determine the MTBF, the mean time between failure. And this is very important to understand. One way is to use a theoretical calculation. I put here in brackets fit. Doesn't mean how fit is the equipment, but fit means failure in time. So for each subcomponent inside the main component, let's say inside the VFD, you have all the parts, and each part has certain failure in time. So this is the number of failures within certain period of time it's per definition 10 to the power of 9 operating hours. So so 1 billion hours, and how many failures happen within this period of 1 billion hours. And you can take each single part inside the VFD, for example, consider the fit rate of that part, and you can calculate overall the MTBF of the VFD with this approach. This approach, in my opinion, is always a little bit pessimistic, because for the definition of the fit of this failure in time, you consider operating conditions as a kind of design conditions, and the real conditions might be more favorable. For example, you consider 40 degrees Celsius ambient temperature continuously, whereas in reality it's specified up to 40, but maybe the average temperature is 20 degrees Celsius. So this is helping for the lifetime and also for the reliability. Or you maybe consider the nominal current that the system is designed for, but in reality it will operate with average load that is lower than the nominal load. So this is the theoretical calculation that is typically providing more pessimistic figures. The other way is to use the field experience. This is also, so this is really a statistical value. You manufacture and commission a certain amount of systems or equipment. You're calculating the operating hours of each equipment, and you sum them up, so you have the total operating hours, and you divide it by the number of the failures for the same period. This is on the other hand optimistic. The reason for that is that the manufacturer might not always get the feedback about any failure. I mean, if the failure happens during the warranty period, then it's usually reported and the manufacturer shall repair it at his own cost. But if the repair happens long time after the warranty, it can be that the customer is rectifying the failure himself, or he is engaging some service company and the manufacturer might not get the notification that there was a failure. Nowadays, of course, if you have some remote monitoring system and so on, then the manufacturer can see it. But if you have large installed base and especially the older equipment, then maybe the monitoring system is not installed because it was not available at the time, or maybe some customers don't allow it due to the cybersecurity topics and so on. So what I want to say, this field experience results typically to more optimistic figures. So if you have a figure of MTBF for a transformer or VFD or motor, and it's not stated what is the base for the determination of the value, then I recommend you to ask back, is it a theoretical calculation or is it based on field experience? Because it makes quite a big difference. If you ask me personally which way is correct, I would say none of them is right or wrong. You just have to be aware of this, that the one is delivering more pessimistic results, the other one more optimistic. In the end, the MTBF is a statistical value, so it tells you something about statistics, and your system might anyway be different. If you would have both values, the theoretical and the field experience, then you can assume that the real value is somewhere in between.
Now let's look at the drive system and some specific figures. So we will look at three main system components: transformer, VFD, and the motor. And if you look at the MTBF, this mean time between failures. For the transformers, I have seen from different manufacturers figures that are ranging somewhere between 1000 and 2000 years. For the VFD, you get typically a range somewhere between 5 to 25 years. The 25 is quite optimistic. but let's say 10 to 15 years is quite common. And on the motor, I don't have really good figures, so I just estimate maybe 100 years. It will be less than the transformer, I assume, because there are rotating parts, there are more components inside the motor. But if we just look at the transformer and the VFD, we see a huge difference, right? And this is sometimes misinterpreted. I mean, here if you look 1500 years for a transformer, so you think how can it even happen? Some people even think, is it correct? I mean, you need to understand this is a statistical value, right? Of course your transformer will not have lifetime of 1000 or 2000 years. It just means that statistically it takes 1000 years until it fails, meaning that most of the transformers never fail during their lifetime, and some of them fail. And then combined you get this statistic, you get this operating hours or operating years, the total operation time divided by the number of failures, and you get the MTBF. So if you have 100 transformers installed in the field and 99 of them will work throughout their whole lifetime without any failure, and one will fail, then you will have the operating hours of all 100 transformers, the cumulative number, and this will be the MTBF because you just have one failure. On the VFD it looks very low compared to the transformer, but this is where I see that the MTBF is not the only figure that you should look at. And there is also the MTTR, so let's look at the MTTR as well. So here we still have the MTBF figures, those number of years, but let's look at the MTTR. For the transformer I put here as an example 2880 hours, which means 4 months. And for the VFD I have 6 hours. Now what it means for the availability. What those figures tell you is basically the probability that the transformer has a failure is very, very, very low. That's why the MTBF is very high. On the other hand, when a failure on a transformer happens, the repair often takes significant amount of time, in terms of weeks or even months. If you have a internal short circuit in the transformer, it depends how quickly you detect it, how severe is the damage. If the winding is damaged, normally you cannot repair it on site. So you need first time to manufacture the winding, you need to ship the transformer back to the factory or to a service shop. If it's oil transformer, you need to untank it, so remove all the oil, take the active part from the tank, disassemble, remove all the clamping, so disassemble the magnetic circuit, take the failed coil out, put the new one, put everything inside, test the transformer again, so repeat all the routine tests and factory acceptance tests, ship it back to site, install it, recommission. So this can take very, very long period of time. If the failure is very severe, maybe the transformer even is damaged beyond repair, and a new unit needs to be manufactured. The VFD has much shorter MTBF, say 10-15 years, so we are factor 100 times lower. But with respect to the MTTR, it's only a few hours. It can be that the semiconductor failed, and with most of the VFDs they are able to detect which semiconductor failed, and then if you have the spare part available on site, it could be even less than 6 hours. If the service personnel is trained for that operation to exchange the semiconductor, he can do it very fast. So the probability that you experience a failure in the VFD is much higher because the MTBF is shorter, but the rectification is also much shorter, so the impact of the failure is relatively small. Whereas the VFD, the transformer has a very low probability of a failure, but if it happens, it has very severe impact. You can have really very long unplanned downtime, and this might be a risk for the operation.
So looking now at the availability of the system components, if you look at the transformer, I have considered 1500 years mean time between failures. So I took something in the middle, and I was considering this 4 months period, the MTTR, mean time to repair. Then I'm getting availability 0.9998, so 99.98%. If I take the VFD and I would consider 10 years MTBF and 6 hours MTTR, time to repair, then I'm getting 99.99%, so even higher than the transformer, the availability. Of course, this is a calculation example, but it should just illustrate the ratio and especially the fact that we should not just look at the MTBF. I mean, the MTBF is just telling you what is the probability that the failure happens. But the other side is like a coin, it has always two sides. One side is the probability of the failure. The other side is the consequence of the failure. So basically for the transformer we can say the probability of a failure is very, very low, but the consequence can be very dramatic. For the VFD, the probability of the failure is higher. So during the lifetime, if it's a lifetime of 20, 25, 30 years, it's likely that you will experience a failure, to be open, to be honest. But in most cases, the failure is minor, can be fixed very quickly. It can be a failed semiconductor that can be replaced almost immediately, or it can be leakage in the cooling circuit system. It can be something. The repair is normally fast. So this is always important to consider. I don't want to make any competition which component is more reliable or less reliable, which one has higher availability. What I want to say is just that the MTBF is not the only figure you should look at. This is a little bit taking the availability or taking it out of the context and just comparing two figures. This one is higher, this one is lower. But you should understand the availability, how the definition works, and thinking just simply practically, what does it mean for you when the failure happens? What are the consequences for your business? During my professional career, I have experienced how difficult it is and dramatic it is for the customer if the main transformer fails. Then basically the whole drive system is down, especially since this is a converter transformer specifically designed for the VFD. It's typically this multi-winding design. It's not a transformer that you can easily rent somewhere. It's a very specific design linked to the specific type of the VFD. So you don't easily find a spare. And if this transformer is not working, then the whole drive system might be down. Maybe the motor voltage is different than the grid voltage, so you cannot operate it direct online. Or maybe even if the voltages are the same, the motor might not be designed for direct online start. So you can have really severe problem, and the repair can take very long time, especially nowadays. If it would be severe failure and the transformer would not be repairable, nowadays the lead times for a new transformer are really long, 1 year and more. So it can be very severe. To help the customers, we have our concept of capital spare transformer. So we have a transformer that is designed a little bit universally. It does not fit every VFD, but it's a little bit universal design to cover at least some portion of the installation in the field. And we can rent this transformer, and The purpose is to bridge the period until the original transform is repaired or a new transform is manufactured. If you are interested in this service, please check the links below this video where you can learn more information. Of course, you can contact us if you have a real case where you urgently need such transformer, but you can also check just the eligibility. You can check whether we would have a solution for you, because as I mentioned, our transformer does not cover every single case, but you can check in advance. Nothing happened, your transformer is working perfectly, but you can just check in case of an issue, could we help you, would we have a solution or not? Then if not, you can maybe look for some other solutions. If yes, then at least you have one possible plan in case something happens. Thanks for watching.